And we're going to review this. This says find the vertex of y equals negative 2x squared plus 8x plus 3. This is a parabola. As a matter of fact, I didn't ask you this, but we know a parabola is U-shaped. And since the a, the number in front of the x squared, happens to be a negative number, that means this is going to be an upside down U. It's going to look like this. It's going to look like a frown because it's in a negative mood. Remember, that's our reminder. By the way, if we want to find our vertex, which was the question, we have to do x equals negative b over 2a to get the x value of the vertex. So we know the a is negative 2, and the b we know happens to be positive 8, because the a is a number in front of the x squared, and the b is the number in front of the x. So sticking it into that formula, and look at, I still had it on the board from last week. We're going to do negative 8, that's negative b, over 2 times negative 2, which is going to give us negative 8 over negative 4, which reduces to 2. Now, we're not finished. When we say the vertex, that's just the x value of the vertex. We have to stick this number into the original equation to find the y value, because the vertex is a point, and the point has to have both an x and a y value. So sticking this 2 into the equation, we're going to get negative 2 times 2 squared plus 8 times 2 plus 3. Notice how in place of the x, I'm putting a parenthesis and filling it in with the 2. Now, you can stick this into a calculator just like this, but if you want to do it in your head or on paper, the first thing you have to do is the 2 squared. The exponents come before multiplication and division. So 2 squared is 2 times 2 is going to give you 4. And I'm going to have to multiply that by negative 2, which will give me negative 8. Plus 8 times 2, that's plus 16. Plus 3. Remember, first do the exponents, then the multiplication or division, and finally the adding and subtracting. Negative 8 plus 16 is positive 8, plus 3 is 11. So the vertex of our parabola that I gave you is 2, 11. You have to put in both numbers because a vertex has to have a x and a y. It's a point. It needs 2 what we call coordinates. Okay. I noticed that a lot of people, or the couple of people that came up with the answer for this on our chat, and there were 3 of, I see Kiana also came up with it. They all came up with the same answer of B. So let's see if B is indeed the true answer. We just put Kiana down as having fun. Okay. Some of these people, some of you are really racking up those extra points. They certainly are going to help when it comes to my figuring out your final grade. Okay, remember this, we see once we have an x squared and a y squared, notice how different these equations are. This had an x squared in it. All of these, what we call conic sections, and they're going to be a total of 4 of them, 4 different shapes, of which we've already talked of 2, the parabola and the circle. all of them I have equations that are quadratic equations. All of them have equations with x squareds or y squareds or both x squareds and y squareds. So we have to see by looking at this, so it's not like a linear equation that it's going to be a line. With a quadratic equation, it could be one of four shapes. We saw this shape of the parabola was this U shape, sometimes facing up, sometimes facing down. Occasionally, it could also face on the side, but we didn't discuss those types. If you do a higher level math class, we'll talk about it. That would be a case. If you notice, in this case, we have an x squared. Remember, we're always looking at the highest exponent. The highest exponent on the x is 2, but the highest exponent on the y is 1. If it would have been sideways, that would have been the highest exponent on the y would have been 2, and the highest exponent on the x would have been 1. Again, we're not just talking about those, but that would also be a parabola where one of the variables has an exponent of 2, but the other one doesn't. That is a parabola, and when we look for the most important point in a parabola is its vertex. We talked about finding its intercepts as well, and that's something we're going to do with other examples as well. Okay, this next equation has x squared plus y squared minus 8x plus 14y equals negative 61. So not only does it have an x squared in it, it also has a y squared. It has other things as well. When I'm talking about the x squared and y squared, those are the highest exponent terms. Those are the ones that determine the shape. There might be other terms that have those variables in them, but to figure out what kind of shape it is, we look at the highest power terms, the highest exponents. And that's x squared plus y squared. Now, when you have an x squared plus a y squared in an equation, that is going to be and basically it's a 1x squared and a 1y squared because they don't have any numbers in front of them. That is going to give us a circle. And a circle, we generally try to find where is the center of the circle and what is the radius of the circle. Now, this is what we not in what we call standard form. We want to put it into standard format in order to find its center and radius. So how do we go about doing that? We take all the x terms and put them together. So that would be the x squared and the negative 8x, and we leave a space. We then put all the y terms together, which would be the y squared and the 14y. And if there's anything else on this side of the equation, on the left side of the equation, we have to bring it to the other side, but we don't, so we just leave it equals negative 61. And what we want to end up doing is getting the x plus something squared plus y plus something squared equaling a number. And in order to do that, we have to do what's called completing the square. Remember how we complete the square? We did that as a method of solving quadratic equations. We're going to have we're going to end up with a binomial squared for the x, and we're also going to end up with a binomial plus something for the y. So how do we do this? Well, of course, the x squared gives us the x. And the number that we're going to put in there is always half of the number in front of the x. So half of negative 8 is negative 4. And the number that we would have to add to this to make this term a perfect trinomial square of this this into a binomial square by making the trinomial into a binomial square is by taking this number, the last number, the missing number is going to be this number, the -4 squared. -4 times -4 is going to give me plus 16. I have to add plus 16. That will make this expression into x minus 4 squared. Well, if I add 16 on this side, I better add 16 on this side. I'm just putting lines underneath it so you know that that's what I added. I do the exact same thing with the y. This is going to be y, and the number next to it is going to be the second term of the binomial is going to be half of 14, which is 7. But in order for that to be 7, I'd have to have a 7 times 7 or a plus 49 over here. And again, and I'm going to make this so you'll see that we're adding 49 to both sides. Now, what does that give us? Well, I think it's easy. Let's add, if you add the 49 and the 16, you get 65, and negative 61 plus 65 is positive 4. If you add up all those numbers, you get positive 4. And now this equation is in what we call the standard form of a equation for a circle, which is x minus a squared plus y minus b squared equals r squared. In other words, once we have it in this basically very neat factored form, the center of the circle is always the numbers inside the parentheses with the different variables. The number inside with the x will give you the x of the center. The b, the one that's next to the y will give you the y of the center. But if you notice, it's always the opposite sign. So therefore, in our case, the a is going to be positive 4, but the b is going to have to be negative 7. The radius is always the square root of this number on the other side. So the radius is the square root of 4, which is 2, which is indeed B. Everybody who picked B, you did it right. It's perfect. Thank you. So that reviews the two types of conic sections that we've talked about so far, parabola and circles. Today we're going to talk about two other types of conic sections, and that will complete our study of, there's much more to talk about of these different types of shapes. But this is, we're just sort of taking the top of the iceberg and just doing a touch of it, so basically that we can recognize and see what kind of shapes we get when we are trying to graph a quadratic equation. So I'm going to erase this. It got very messy, so I'm going to erase this. So the third type, and I'm going to call it 3 because it's third type, is something called an ellipse. The next two examples, types we're going to do, we're going to really just do much more simple types than we did with the other two. what does the equation of an ellipse look like? So I'm going to give you the basic equation. And I'm going to discuss how we go about graphing it, and we'll talk about the shape of the ellipse. The basic the standard equation of an ellipse is something like this: x squared over a squared plus y squared over b squared equals 1. And the shape of an ellipse you probably heard the term elliptical or an elliptical orbit. The shape of an ellipse is sort of like I guess, a football or an oval. It's as if you would take a circle. Let's think about, you have a very round balloon and you started squeezing it. So it's not totally round, it gets flattened out. Sometimes it's flattened out horizontally, sometimes it's flattened out vertically. That's the shape that an ellipse has. The Earth itself, I know it's not two-dimensional, it's three-dimensional, but basically is not a perfect circle, not a perfect sphere. It's really, if you've ever studied a little bit about, I guess, geography, you know that it's like sort of pushed in at the poles. It's wider from around the equator than it would be as if you were going across the poles. It's less, the diameter is less that way. So that's an example of really this type. I mean, this is exaggerated, but if these were your north and south poles and this would be your equator, that would be an ellipse. So obviously there seems something close in the ellipse to a circle. And if you look at the equation that I wrote, I didn't tell you what the A and the B are. Obviously in each, they'll be different for each different example. The equation of the ellipse also has an x squared and also has a y squared in it, just like the circle did. Except if you remembered, in the equation of the circle, you just had x squared and you just had y squared. You didn't have anything in front of it. You didn't have it divide by anything. The coefficient of the x squared and the y squared were always the exact same numbers. The way we write, we always put it as a 1. Here, sometimes we'll write the x squared over something and the y squared over something. But these two numbers, which are the coefficients, this is 1 over a squared is the coefficient of the x squared. 1 over b squared is the coefficient of the y squared. Those two numbers are different numbers. It isn't just a plain x squared and a plain y squared. There is a number either in front of the x squared or under the x squared. Sometimes it's written one way, sometimes it's written the other way, and I'll show you both ways. So one example of an ellipse in standard form could be something like this: x squared over 25 plus y squared over 9 equals 1. This is the an example of an equation of an ellipse. Again, notice the two numbers, the A's and the B's, are different. If the A's and the B's would be the same number, we would have a circle, but the circle is generally not written that way. But when we have an ellipse, these two numbers are different. Now, how does that help us? Well, this a squared is the number underneath the x squared, which in this case is 25. Now, if you recall, if we have a squared equals 25, that would mean that a would have to be either the plus or minus the square root of 25, which is 5. The a gives us the x-intercepts. B squared is the number that's underneath the y squared. In this case, the b squared is 9, which would give us that b could be either plus or minus the square root of 9, which is 3. The b gives us the y-intercepts. We are talking about an ellipse whose center is at the origin. We're not going to go into, there are ellipses that could be centered other than in the origin, but that's beyond the scope of this course. We're going to be talking about only ellipses that have their center right here at the origin. Remember, we started out talking about circles whose center was at the origin. And we said, if you remember, a circle whose center was at the origin had an equation x squared plus y squared equals r squared. So if you compare this equation to this equation, you see the difference. This has different numbers under the x squared and the y squared. It's not just a plain x squared and y squared. Okay, so coming back. Sorry. Coming back to our equation, we said that the two x-intercepts would be plus or minus 5. That means on my piece of graph paper, I'll go 5 to the right, here, to get to positive 5, and 5 to the left to get to negative 5. Those will be the two x-intercepts, the two places where the graph will cross the x-axis. On the y-axis, I'm going to go up to 3. And then I'll also go down to negative 3. Those are my two y-intercepts. And if I connect these and don't make straight lines, you see that what we get is an ellipse, an oval shape. That's how we graph an ellipse. An ellipse could be centered other than at the origin, but again, that's beyond the scope of our course. We're just looking at the very basic, simplest type of ellipse, the one whose center is at the origin. And see how important the numbers, the a and the a squared and the b squared are, because it gives us where it is crossing the x and y axis so that we can draw a decent picture of the ellipse. Let's see if I can. Okay, so I'm going to give you one to try. I'm going to before I give you one to try, let's talk about, there are two important, let's go back to this. This is our x squared over 25 plus y squared over 9 equals 1. If you notice, the ellipse is cut in half two ways. It's cut horizontally by the x-axis, it's cut vertically by the y-axis. The line that these are called the axis of the ellipse are the lines that cut it, split it. The longer one, and you have to look at it, the longer one is called the major axis. And the shorter one is called the minor axis. It turns out, in this case, our major axis is along the x-axis. It does, sometimes that's when we have a wider than taller ellipse. The minor axis in this case happens to be along the y-axis. And we could even say how long the major axis is and how long the minor axis is. The major axis is going from -5 to 5. So its total length is 10. In other words, it's going from 0 to 5 in one direction and going from 0 to -5 in the other direction. So the total from one end, it's like, we know that the diameter is double the radius. Here, since the whole length of this major axis has to go from -5 to 5, it's going to be a total of 10. The minor axis is going from -3 to 3, so its total length is 6. So that's an interesting piece of information about an ellipse. We have to know to recognize an ellipse from its from its standard format, we have to be able to graph it. So now I'm going to give you one to try. Suppose I give you this example. X squared over 9 plus y squared over 16 equals 1. And we can recognize this as an ellipse because it has an x squared over something plus a y squared over something equaling 1. It's an ellipse. I want you to find the x and y intercepts. And then after you do that, we're going to do a sketch of the ellipse. And while you're doing that, I'm going to take attendance. Olivia. Am I okay? I'm getting over whatever I had this weekend. I'm okay. I'm just a little bit under the weather. Thank you for asking me, Jean. Isis, I see you're here. Elviro. Elviro here. Lewis Hart. Emma.
I'm here. Good
Yes.
morning.
Good morning. Demetrius.
Good morning.
Good morning. And Isis, I knew you were here. Thank you. Desmond. Shania. Kayla, I know you're here. Sanjita. Ariana, I know you're here. Tahira, you're here. I know you're here. Michaela. Kiana, I know you're here. Carleaf, I think I know you're here. Good morning. Jenna, I know you're here. I see you're here.
I'm here. Good morning.
Good morning. Tatiana. Naya. Kazandu. Trina. And Jean, I thank you for your kind wishes. Okay. 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 All right, let's see if we can get this problem done. Okay, I'm going to erase this one over here. And let's see if we could first find the X and Y intercepts, and then we'll talk about how we could draw a picture of it. And we'll also talk about which is the major axis, which is the minor axis, etc. This is from the last problem. So. Yeah. So again, I gave you an equation of an ellipse, which we recognize. Got this x squared over something plus y squared over something. But in this case, the a squared happens to be 9. And the b squared happens to be 16. Again, the a squared is always a number under the x squared. The b squared is always a number under the y squared. If the a squared is 9, that means the a could be either plus or minus 3, which means that this is, remember, the a is your x-intercepts. So you could say your x-intercepts are plus 3 and minus 3. More accurate is to say the x-intercepts are 3, 0, and -3, 0. Because when you have an x-intercept, your y is always 0. So the a is giving you the x value. So we know that this is going to cross the x-axis at either 3, at both 3 and -3. The b squared is 16, which means your b will either be plus or minus the square root of 16, which is 4. Now, if the b is either 4 minus 4, this is what gives you the y-intercepts. So the a gives you the x-intercepts. The b gives you the y-intercepts. Again, it's okay to say that your y-intercepts are plus or minus 4, but more accurate is to say 0, 4, and 0, -4. Again, sometimes they will let you get away with just saying the number. Sometimes though, especially if on a multiple choice question, they might write the answer like this. If they ask, what's the y-intercept? You would have to, and they write it as points, the x value on the y-axis is 0. So the y-intercept would be 0, 4, and 0, -4. I didn't ask you to do this, but now we're now going to sketch this. Here are two x-intercepts, 1, 2, 3, 1, 2, -3. Here's 3, 0, here's -3, 0. The y-intercepts are 4 and -4. Again, this is 0, 4, this is 0, -4. If you notice, it's an oval shape. Again, it's an ellipse closer to a circle because the x and the y-intercepts are close together, but more a vertical ellipse than a horizontal ellipse. In other words, in this case, our major axis is along the y-axis, and our minor axis is along the x-axis. Sorry. That's for this particular example. It's always easy to see if you sketch it. What's the length of our major axis? It's from -4 to 4, so it's a total of 8. What's the length of our minor axis? It's from -3 to 3, so it happens to be 6. So once you recognize that what you have is a ellipse, then it's relatively easy to sketch it. Okay, and again, it's not hard to find. We're only doing the ones whose center are at the origin. So therefore, we only have to, it's relatively easy to find the X and Y intercepts once you know the equation. Okay, so I want to go a little step further. What if your equation is not in standard format? So what kind of format could it be given in? So sometimes you will see an equation that looks like this. 4x squared plus 25y squared equals 100. This is an example of an equation that I recognize has to be an ellipse. How do I recognize it? It has an x squared and a y squared in its equation. It's not just x squared or y squared, it has both of them. But it's not a circle because the numbers in front of the x squared and the y squared are not the same number. We always look at a circle as having a 1 in front of the x squared and 1 in front of the y squared, but it could be, it could be 25 x squared, but then it would have to also be a 25y squared, and then we just divide it out. That's why we only look at it as 1. But once you have two different numbers in front of the x squared and the y squared, everything is positive. There's no minuses here. Again, the x squared and the y squared have to be on the same side of the equation. And everything has to be positive. But the number, and again, we're dealing with those that have just a plain x squared and a y squared. There's nothing else in this equation except a plain number. We'll recognize that it's an ellipse, but it's not in standard format. Because in the standard format, we have the x squared over something and the y squared over something, and it equals 1. It doesn't equal a number. So how do we put this in standard format? Well, we just look at this number that's on the other side of the equation. It's 100. I'm going to divide that by 100 because 100 divided by 100 will give us 1. We need it in standard format to equal 1, which means I have to divide everything by 100. So I divide by the number on the other side of the equation, and I simplify. Well, the 4 into the 100 will cancel out and give me 25. So I'll get x squared over 25. And the 25 over 100 will cancel out, and that'll give me y squared over 4. And that equals 1. And now I have the equation in standard format. I have to, even if it's not given to me in standard format, I've got to transform it to standard format. And then I'm going to can figure out what my a squared and my b squared are. My a squared is the number that's underneath the x squared, which is 25. Don't make the mistake of looking at the original equation and saying, oh, the a squared has to be 4. The a squared, this is not this 4 over here is not the a squared because it's not underneath the x squared. It's not in standard form. In this case, the b squared is 4. That means the x-intercepts are plus or minus 5. And the b, the y-intercepts are plus or minus 2. So then I can now sketch this graph where the a, I'll go to 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 on the x, and on the y, 1, 2 up, 1, 2 down, And I would get a graph that looks like this. So don't try to graph it until you put it in standard format. Then it's easy to see what your X and your Y intercepts are. I'm going to give you a question to try. They want you to graph this ellipse. This comes off of a final. It's 16x squared plus 25y squared equals 400. Okay, I'm going to give you a few minutes to try that. Okay, let's see if we can work this out. I'm gonna erase this and work it over on this side. I gave you that the equation is 16x squared plus 25y squared equals 400. So we know we have to put this in standard form. We know it's an ellipse. It's got a x squared and a y squared with a plus, everything's plus. But the numbers in front of the x squared and the y squared are different numbers. We have to put this in standard form, so we're going to divide by this number over here, which is 400. So I divide the 16 into the 400, and that gives me 25. So I get x squared over 25. You'll notice it usually works out that the number in front of one is the one that's underneath the other one. The 25 over 400 gives you y squared over 16. And this gives you 1. So compare the original equation with the new equation. You see how it sort of shifts. The 16 went under the y squared, the 25 went under the x squared. I can't tell you that this will work all the time, but I would say 95% of the time that's what happens. that's telling you that your x-intercepts, your a squared is 25, means your two x-intercepts are 5, 0, and negative 5, 0. Your b squared being 16 gives you that your y-intercepts are 0, 4, and 0, negative 4. Remember, with the x-intercept, the number goes first, the 0 second, because it's on the x-axis. That means the first number is the left to right, the second number is the up and down. But on the y-axis, the 0 goes first because the number up and down is 0. It's giving you, the side to side number is 0, it's just going up and down. And again, once you know these numbers, then you could draw your ellipse. I don't think I have to draw it for you. I think you get the picture. So I want to give you, another question. I'm going to give it one that's like a sort of thinking out question and see if you could come up with the right answer. This is a question that was on a past final, and it's going to be a multiple choice question. Here's the question. Give the equation of the ellipse with the intercepts 3, 0, negative 3, 0, 0, 4, and 0, negative 4. Here I'm going backwards. I'm giving you what the intercepts are, and I'm asking you to write the equation. And this is, as I said, this is a multiple choice question. So here goes. A is 16x squared plus 9y squared equals 144. B, 9x squared plus 16y squared equals 144. C, 16x squared minus 9y squared equals 144. And D, 9x squared minus 16y squared equals 1. Okay, these are the choices I'm giving you. See if you can figure out, here are the intercepts of the ellipse. It's told me it's an ellipse. We're told that it's crossing at these 4 points. It might be a good idea to do a quick sketch of it. And see if you could write the equation of the ellipse. And I'm going to do it first open-ended, and then I'm going to go back and say, well, what if I didn't know, but if I looked at the answers, would I be able to tell? Okay, but I'm going to give you a few minutes to try it on your own. If you have, or you think you have the answer, put it on the chat. No, we're doing this question. The question is here. These are the intercepts. And I want you to find the equation. I think we finished that one already. If these are the four intercepts of an ellipse, which of these is the right equation? Okay, should we start working on it together instead of asking you to guess? Okay, I guess I'll do it just straight from, since it's this is the type of question that would be a multiple choice, so I may as well go according to the multiple choice. If I look, these are my choices. If I look at them, A and B look very similar. One says 16x squared plus 9y squared equals 144. And the other one says 9x squared plus 16y squared equals 144. I recognize these both as ellipses because they have an x squared plus a y squared, but the two numbers in front of the x squared and the y squared are different. That makes them an ellipse. If I look at choice C and D, I can eliminate right away because I told you I wanted it to be an ellipse. The question was find the ellipse that has these 4 points as its x and y intercepts. If you notice, the difference between equations A and B and C and D is that C and D both have x squareds and y squareds in them, but there's a minus in between them. That kind of an equation with an x squared and a y squared is not a circle, it's not an ellipse, it's the 4th type of conic section that we're going to be talking about. I'm not even going to give you its name right now. We're going to do it right after we finish this discussion. But we know it can't be an ellipse because between the x squared and the y squared in an ellipse and in a circle, it has to be plus. Both the x squared and the y squared have to be positive. In this case, the x squared is positive, but the y squared is negative. In this case, the x squared is positive and the y squared is negative. Sometimes we have where the y squared is positive and the x squared is negative. That would not be an ellipse, that would not be a circle. So right away, I can eliminate choice C and choice D because they have these minuses. So then I go to, we have to pick between choice and A or choice B. But neither A nor B are in standard format. So let's first start with A. 16x squared plus 9y squared equals 144. Let's put that in standard format. Let's put it in the x squared over a squared form plus y squared over b squared equals 1. And then we'll see what its in x and y intercepts are. And if it matches these, then we've got the right answer. And if it doesn't match these, I've got to try number B, but it probably has to be B. Okay, so notice we were able to eliminate two of our answers right away. If we recognize the type of equation we have, we'll know that if they're asking for an ellipse, it has to be an x squared plus a y squared with different numbers, either on top of, next to the x squared and the y squared, or underneath them. All right, putting this in standard form means I'd have to divide everything by 144. And remember how this usually turns out. Over here, the 144 gives us 1. Here, the 16 over the 144 is going to give us x squared over 9. You could just check that out. 144 divided by 16 is 9. And the 9 over the 144, when you divide the 144 by 9, you get 16. So this gives you y squared over 16. Notice we have now taken example A and put it in standard format. We see clearly it is an ellipse. And since the A squared is 9, that would mean the x-intercepts have to be either plus or minus 3. And the B squared is 16, which would mean the B is plus or minus 4. So this is the one that has 3 and -3 as its x-intercept. Remember, in the x-intercepts, the number comes first, the 0 second. And the y-intercepts are 0, 4, and 0, -4, just like it says over here. So we have to pick choice A. I don't even have to look at choice B, but don't make the mistake of seeing the 9 in front of the x squared and saying, oh, has to be 3 and -3. It's only when the 9 is in the denominator. It has to be in standard form. So eliminating the choices that don't make sense, and very often there'll be something like that, you can get the answer without a lot of work. But just remember, it's the A's and the B's, the numbers that are underneath the x squareds and the y squareds, that'll help you find the x and y intercepts. Okay, so having said that, let's go on to the last type of conic section, the one that has equations like in C and D. Is everybody okay with me erasing this right now? Okay. So that the last type of conic section is something, it has a very strange name. It's something called a hyperbola. I don't know where the name came from. I've heard the term hyperbole, but I don't think it has anything to do with this. It's hyperbola. Now, a hyperbola happens to be not only a strange name, it's a strange shape. There are two ways a hyperbola that we're interested in. Again, we could go into much more complicated examples. We're talking about the basics that you have to know for this course. There are two ways the hyperbola could look. It's always made up of two branches, sort of like back-to-back parabolas. It's not really the same shape as a parabola, but it's, if you think about it, it's two back-to-back shaped U's. It's two branches back to back. sometimes sideways, sometimes up and down. So first of all, they have to be, and they're, I know what my picture doesn't look like that, but they're basically identical except flipped. They're, I guess you call them symmetric, or I don't know how I'm gonna do it, just go out like this. They're sort of mirror images of each other, these two branches. Okay, so you can have what I'll call a vertical hyperbola, or you can have a horizontal hyperbola. Usually we're going to be talking about only those that are centered at the x-axis. So you'll have the x and y centered at the x and y axis. You'll have the axes going through. I'm doing this in green just so that you can see that this is not part of the picture. It's just, these are the axes, and it's sort of, notice the vertical ones cross the x-axis, and the horizontal one don't cross the x-axis, they cross the y-axis. And that's one of the main features of hyperbola. First of all, they're these back-to-back. We're not going to go into detailed drawing, but we're going to be able to recognize what it looks like by looking at its standard equation format. So when you have the hyperbola crossing the x-axis, in other words, you have this vertical, looks like the tree trunk if you think about it, you're going to get an equation that'll look like this: x squared over a squared minus, look at, that's the important thing, the minus in between them, y squared over b squared equals 1. That's the standard format of a vertical hyperbola. The standard format of a horizontal one that's crossing the y-axis and not the x-axis, is going to be y squared over b squared minus x squared over a squared equals 1. So sometimes you're going to see the x squared is going to be the positive one, and it's going to come first. And that's the one that's going to cross the x-axis. And sometimes you'll see the y squared coming first. And that'll be one that crosses the y-axis, but not the x-axis. Let me mention, because there's a minus in between them, you could even have the A's and the B's could be both ones. It could be as simple as that. The A and the B do not have to be different numbers, because there already is a difference. It can't be a circle because there's a minus in between them. So when there's this minus in between them, whatever the A and the B is, they could be the same number. Remember, with an ellipse, if the A and the B were both 1, you'd have a circle. So to distinguish between a circle and an ellipse, we have to make sure that these numbers are different. But this is already different from the circle because of the minus, so the A and the B could be the same number. So I could have an example that looks like this. I'll start with a simpler one, and then I'll suppose I gave you x squared over 4 minus y squared over 9 equals 1. I right away would recognize this to be a hyperbola. It has an x squared in it, it has a y squared in it, and between the x squared and the y squared, there's a minus sign. It's also in standard format. If it's not equal to 1, then we have to put it in standard format just the same way we did it with the ellipse. But this is already in standard format, which is telling me that my a squared is 4 and my b squared is 9. Now, look at it. Whichever is the positive one, which in this case is the x, that's the one that's going to have the intercepts. There are going to be x-intercepts, but no y-intercepts. In other words, I don't need to know what the b squared is. It is 9, but it doesn't help me because it's not going to give me intercepts. The hyperbola will not cross both the x and the y axis. It will only cross one of them. And that's the one that starts out, the one that's positive. So in this case, if the a squared is 4, that would mean that the a has to be equal to plus or minus 2, which means that if I were looking for, and if I were trying to sketch this, there are other things to be done, but you don't have to be, there are much more complicated things that could be done with this. But I'm just giving you the very basics. You look for a hyperbola, your two branches, where the two branches are going to cross the x-axis. Now, sometimes they open wider and sometimes they open narrower, but when you're going to have to pick one out from a series of pictures, I don't know if you're going to be able to see this, but you see there are a bunch of pictures here. You look for where that you're getting the hyperbola that has the proper intercepts. It'll either have an x-intercept or a y-intercept. In this case, when it starts with x squared being the positive one minus a y squared, it will have x-intercepts. The x-intercepts in this case are plus or minus 2. Okay, I'm going to give you one to try. I'm going to sort of sketch one for you. I'm going to need a lot of board. Suppose I gave you this equation. Y squared over 49 minus x squared over 64 equals 1. That's the equation we're being given. And we're asked to graph it, and they give us 4 basic graphs. And I'm going to try and graph them for you. That was choice A. Here's choice B. See if you could, I know it looks a little bit, I'll describe them because they're a little bit hard to see on the board, but I'll describe them. This has branches going crossing the x-axis at 7 and -7. This has two branches crossing the x-axis at 3 and -3. This has y branches. I know this one looks, this should be like this better. Has branches crossing the y-axis at 7 and -7. And this has branches crossing the y-axis at 8 and -8. So this is 7. You have to be careful. This is -7, and this is -8. You have to look on the picture. You have to look very closely because they look very similar on the picture. I'm going to hold it up so you can see. So I'm giving you a minute to think about it, and then we'll talk about it. If you have an answer, you could put it on the chat. Even if it's wrong, it's better than nothing. Okay, I think we should just talk about it. If you notice, when I gave you the equation, this is of the form y squared over b squared minus x squared over a squared. The y squared is the positive one. They put it first, but the important point is that the y squared becoming positive means that there are y-intercepts and no x-intercepts. That's what it means when we see it's a hyperbola with an x squared and a y squared, but the y squared is positive and the x squared is coming after the negative sign. The x squared is negative. There are going to be no x-intercepts. So right away I can cancel out or cross out choices A and C. Now the question is, what are my y-intercepts going to be? So I have to look at the number that's underneath the y, which means the b squared, which is 49, is telling me that my y-intercepts are plus or minus 7. So obviously they have to be choice B. Choice D is wrong because it has y-intercepts of plus or minus 8. Okay, I'm going to stop right here unless somebody has a question. We'll continue. We're going to be starting a new topic on Wednesday. Don't forget that this Friday, Black Friday, there is no school. There is no class, there's no school, and there's basically, after this, 2.5 weeks. So you should be on the lookout for a study guide from me, and you should be starting to study and preparing for the final exam. I'll shortly be sending you out a practice final. I haven't gotten it yet, but once I get it from the department, I will send it out to you. But don't forget, there is quiz number 4 has been posted and is ready for you on Delta Math. You have until the end of the term to complete all your work. Okay, have a good day, everybody. I hope to see you on Wednesday.
Wait, I have a question before you leave.
Sure.
On Delta Math, it's not letting me do the extra credit.
There was an extra credit example and it's not giving me, and then I'll open it up and restart it.
Okay.
Okay?
Okay. Thank you.
Okay. Any other questions?
No.
Okay, everybody, have a good day. Stay well.